We are today we're going from polar to rectangular coordinates. You've done this, but you didn't know it. But you've done this before. How many remember finding the vertical and horizontal vectors? Remember that? What did we use to find the horizontal? What did we use to find the horizontal vector? That's right. Isn't horizontal the same as the x? So what did we use? Cosine. Remember? What goes with x? Cosine. If we found the vertical, you used sine, didn't you? So if we want to find x and y of a polar coordinate, let's look at the first one there. You need to put your book away, Kyle. Okay. Let's say we have 5 comma pi over 3. That's the first example. So if I want to find the x comma y, x is horizontal, y is vertical. Here's what we did. We just took r, remember this is r and theta. We just took r times the cosine of theta to get the x. That's what we did when we found the horizontal vector. And doesn't it make sense that you'll take r times sine theta to get the y? Yes? Now if you're going to use a scientific calculator, which you should be using, you've got to change pi over 3 to degrees. Yes. How many know that's 60? You should know that. What's the way to figure it out if you didn't know that? Remember what I taught you? Just divide 180 by 3. Yep. 3 goes into 180 how many times? 60. Now if this would have been a 2 pi, then you take 3 into 180 times 2. Just do that. All right, so really what we're finding is 5 times cosine of 60 to find the x, 5 times sine of 60 to get the y, and what do we get? Round these to the nearest hundredth. Well, I'll take tenths. What do you got? Anybody done it? Do what now? I got 1.5. What'd you get for the x? Oh, I'm sorry. I'm doing the wrong one. I'm looking at the second one. I used the wrong number. You're right. 2.5. Now, what do you get for the y? Okay. So this is the x comma y, or the rectangular. This is the polar. So you need to know the difference. That's what we've been doing. This is polar, and this is rectangular. Makes sense because remember the xy axis is a rectangle, right? Okay. Anybody need to do another one, or do you think you got this all right? Now guess what? This is the answer, or the way you do number 10 on your test that you just took. But I didn't show you this because there's another way to do it. What was the other way we did number 10? Some of you did it correctly. Edwin? Pythagorean theorem on number 10. So if you all want to see this, remember you can find r by doing this too, can't you? Remember this Pythagorean theorem we had? R squared equals x squared plus y squared. So if you have an x comma y, you can plug those in and get your r. Now how do we find theta? No? Tangent inverse. Don't we have a y and an x when we have an ordered pair here? For example, if we had this, we'd have a y and an x, wouldn't we? Tangent's y over x, isn't it? So to find theta, you should have done the tangent inverse of y over x. But you're not done just by doing that. You also got to know which quadrant you're in. So you have your x-axis is where your reference angle will be, but you have to figure out what quadrant am I in. Do I add it to 180? Do I subtract it from 180, or do I subtract it from 360? You'll have to think about that. Anyway, I wanted to tell you that for some of you. How many got number 10 right? There were about 3 people. Okay. All right, let's go on to the next thing here. You all need another practice on that? Because I got another one there if you want to try it. You can try it later if you want. Now you'll notice, I'm going to rewrite this up here. I had these written here on your paper because we're going to use these. And to find a theta, we do tangent inverse of y over x. Now you don't really need that second part because you'll know what to do with it by what quadrant it's in. Most of you should know how to do that. All right, let's look at number 2, example 2. It says find the polar coordinates for r, which is that -8? I got a line through it. Okay. Go ahead and see if you can find that. I just showed you how to do it. We want to change this to polar, which means we need an r comma theta. See, r's and thetas are polar, x and y is rectangular. Is this a Pythagorean triple? Then you need to just round it to the nearest hundredths. So, what do we get for r here? Let's see here. I'm going to plug it in just for this here. So we have r squared equals 64 because we have this squared, and that's going to be 144 when we square that. So r squared equals, what was that, 208? So take the square root of that and we get, yes. I'll take it hundredths or tenths since it's not a big deal. How many got 14.4? Good. So that's our r. Now if we want theta, we have to do the tangent inverse. So we'll do tangent inverse y over x. That's really -12 over -8, which is really the same as, what is that, 3 halves, or no? Yeah, 3 halves. Now, here's the thing. When you do this, though, that's not your answer. It's your reference angle. So tell me what you get with your scientific calculator. Let's round it to the whole degree. What do you get? No, I mean, I want the first. No, I want this before we find it. I hope you all are doing this with your calculator so we know what we're doing. Of course, you all don't have any, do you? I always have to give out 10 calculators in here. It's going to be 68 degrees, isn't it? Rounded to the nearest degree. Oh, I know why. I'm looking at the wrong one again. I got 56.3. Is that right? Yeah, I looked at the bottom problem. Yep, 56.3, and you can round that to 56. Now, that is not our answer. Why? Because where is this? Isn't that in the third quadrant? Negative, negative. So that means our 56 is on the x right here, isn't it? Which means we need this angle. So what do we have to do to get it? Add it to 180, because we're going past 180, 56 degrees, aren't we? Are you following that? So what'd you say, 236?
Yes.
So you're going to have to pay attention once you find your reference angle. Look at your ordered pair, see what quadrant you're in. Then it becomes your reference angle in that quadrant. Obviously, since we went past this, we had to add that, didn't we? Okay. Let's do another one. Try this one on your own. Find 2 comma -5 for me real quick. See if you can find the polar coordinates for that. -5. Put that up here. We're going to be cutting it close, but I think we'll make it here. Survey took up some time. Actually, if you want to write it, you could write it like this, because that's what we're really doing, aren't we? So if we round that, we would have what? Okay. We get 5.4. This is our R. Because we're doing R comma theta. Now we need the tangent inverse. Of that. And this is the one I said earlier, isn't it? To get 68 degrees when you put it in your calculator. Yes? But that's not our angle, that's our reference angle. What quadrant are we in? Yeah, right 2, down 5. Fourth quadrant. So our 68 is here, isn't it? So we want this angle. So what do we got to do to find that? Doesn't it make sense we'd subtract from 360? This is our reference angle. We need this one. So what did we get? 292. How many got 292 on this? Give yourself 2 bonus points, 1 for each. And that's how we write polar coordinates from rectangular. All right, next page on the back. Now we're going to do polar equations to rectangular equations. We're given this polar equation. Now here's what you're going to be using. You're going to still be using this and the fact that x equals r cosine theta, y equals, r sine theta. Now, this is a polar equation because it has r's and thetas. X equals r cosine theta, y equals r sine theta, doesn't it? So see here, this is what you got to recognize here. Here's the polar equaling the rectangular, isn't it? X and y's, this means polar. Same thing here. We've got rectangular equal to a polar form, so we can do some substitution. Go from one to the other. Now, we don't have r here, but couldn't I multiply both sides by the same thing? Isn't that a valid algebraic thing to do? So why not multiply both sides by r? Why do you think I'm doing that? I'm sorry, it doesn't have an r in there, does it? Because I was looking at it and I thought, no, this is not right, because it wouldn't have an r there. Sorry. Yeah, this was just 6 cosine theta on this side. Well, the reason I would do that is because what do I end up over here? R squared. And don't I end up with 6r? I was getting ahead of myself. Don't I end up with that? Now, does anybody see some substitutions you can do now? We want to get rid of the r's and thetas and have only x and y's. So what can I put on this side? Yeah, doesn't r squared equal x squared plus y squared, and we've changed that to rectangular, haven't we? What can I substitute after the 6 over there? Yeah, what does r cosine theta equal? X. Now, isn't that rectangular? All x and y's, isn't it? So that's your rectangular form. If you were going in reverse, you'd substitute in reverse. If you have an x squared plus y squared, I can put an r squared in place of it. If I have an an x, I can put an r cosine theta in place of it. So you're going to be going back and forth. So I'm not going to try on your own, because you could probably do that pretty easily, because you do the same thing. Do you see what you do? Just multiply by r. What would we have this time, though, on the right side instead of x? Wouldn't we have a y? Yeah, 4y, because it's a sine. Okay. Now let's do example 4 so we can get this done here. Example 4 gives you this rectangular. Anybody recognize what this is? You know what kind of figure this is? It's a conic. Probably not. It's a circle. If you don't remember that from Algebra 2. Now, we want to change this to polar, so you're going to have to square this binomial first. Remember how to do that? Anybody remember the 3 steps of the shortcut? Square the first, twice the product, square the last. If you can't do that, you need to separate it into 2 parentheses and FOIL it. Now, what can I do with the 9s right away? Yeah, don't they cancel? Now I'm going to rewrite this. Let's see if you can see what I'm going to get here. The 9s are gone. I want a polar equation. This should look familiar. I moved the 6x over. You'll see why in a second. Polar equations, we want r equals. Can anybody see what we can substitute? Yeah, what did we say this equals? X squared plus y squared equals. All right. Do you see why I put them together, though? Now I can put r squared in here, and what can I put in place of the x? R cosine theta. Now we wouldn't stop there. Divide both sides by r, so we can have r equals. And then your final answer would be r equals 6. So this rectangular is this equation in polar form. Pretty straightforward. Is everybody okay? Do you want to try one on your own for bonus? We have time if you want. Why don't you go ahead and try the last one for bonus? I'll give you bonus points if you get that right. Oh, and that's supposed to be equals 4. I forgot to change it. That's a mistake. It's equal 4, not 8. It can be done with that, but I don't want to get that complicated right now. Pretty quick, pretty easy. Hopefully through all this you're beginning to make a lot of connections, like from when we did vectors and x and y's, horizontals, verticals, r's and thetas. What do we get when we square this binomial? Thanks for doing that. I really appreciate it. What do we get when we square this binomial? Thank you. Then it's getting pretty obvious what you're going to do next. We already have the x squared plus y squared here. 4's cancel. Oh, that's a positive, isn't it? Moved it over. So what's our final? Well, our next step would be this. So the polar equation would be r equals 4 sine theta. How many got that okay? 2 bonus points, and that's all you need to know. You'll get your class time tomorrow to work on that assignment. It's stapled to your notes.